Hello and welcome to day 10. So today we kind of have a map pathfinding problem. So we're given a map in ASCII art and then we're trying to find the longest length of a pipe. So basically our input is like the pipe symbol itself connects up and down. The left symbol or the L symbol connects up and right, and so forth. There's all 6 options. Periods or ground, we can just ignore them. And then one of them is going to be replaced with an S for the starting location, and the S can be any of the 6 symbols, and we have to figure out which one connects the pipe. One issue I had today is down here. It says find the single giant loop starting at S. There's not one single giant loop starting at S, at least not with my input. There were 3, so I was just finding a loop and said return, and that was good, and apparently that's not good. You need to check all 6 options and return the best. So if that's your problem, there you go, freebie. All right, so we'll go through our part 1, take an input into a grid, usual, same as usual. And then, as I said before, we're gonna do a replacement of the start location for each of the 6 symbols. And basically the way I do this is our grid, I'm just going to set the start location as whatever the replacement is. Our current is going to be the next neighbor, and then our last is start. What that neighbor is, I made a helper function. So depending on the point and what item we got, it produces both connections. So up and down, left and right, whatever, so J is left and up. So here's left and here's up. And basically, that just gives me a pair of each. To start with, I know the first one's the first one, so it doesn't really matter. But then after that, while we haven't hit the start, and we're still inside of the grid, and we're not on the ground symbol, if we had any of those, we just cancel out. We don't have a path, so it's okay. Then we're going to add the current one to our list of visited nodes, and then we're going to get the neighbors, and then whichever neighbor we did not come from, we're going to go to. If it's something that we've already hit before, then we're done. If not, then keep going. And then basically, I'm just going to return the max size divide by 2. That's probably something worth pointing out. Is we want the furthest distance, so not the length of the pipe. We want the furthest distance, which is just going to be over 2. So I think that was it for part 1. Okay, part 2. We want to find how many spots are wholly contained inside of the longest pipe. So there's a couple caveats on this. Basically, like this part is not contained inside of the pipe, right? Because it has a outer connection. That's all well and good. A standard fill algorithm will do that. The problem is if even if the pipes are touching, this is not contained because this hole here in the middle still could be used. So you can squeeze between the pipes, you just can't be inside of the loop completely. So what I did is I added a fill grid, and let me just kind of show you, I'm not going to walk through the whole algorithm. I'm just going to show you kind of what it's doing. But basically, I'm going to double the size of the grid and then do a fill algorithm on that double and then shrink it back down. So I double the size of the grid and I move everything to x to x times 2 and y to y times 2, etc. And so like for the example that we have here, and again, I'm only doing it for the items that are actually in the cycle, because even pipes that are not in the cycle are still considered gaps. So I send in my cycle, my longest cycle, and then I do it that way. So our longest cycle is basically this pipe here. It's like F down, L down this way. And so I map them all to a grid that's twice as big in both directions, and x times 2 and y times 2 for all the coordinates. And then I use my neighbors algorithm again to just go through and find the neighbors of them and put those in as just hashes. It doesn't really matter. It just needs to be not a space or a period. And so then I start with the outer shell with periods, and then just do a standard fill algorithm. So basically it will go from here and then it'll find the neighbors and put all the neighbors onto our queue, and then it'll pop the next line of the queue, and then it's like if it's here, it'll pop all, or push all of our neighbors on. If it's already been done, it skips them. Otherwise, it keeps pushing more neighbors on it until it fills up all of the gaps. But by doing it as a ×2, like for example, this spot right here, this is between two pipes normally. So this J pipe and this F pipe are touching, but there's still a hole here. And if it was in the normal grid, you'd have to sit there and try to figure out when you can squeeze in and when you can't squeeze in. But by doubling it, now there's an air gap here, and so the standard fill algorithm just works as normal and fills in the space. And then once we're done, then I can go ahead and shrink that back to a normal size map. So exactly the same thing, just divide by 2 instead of multiply by 2. And now I have some spaces here where there aren't any, where there were no connections to the outside. So those are our gaps. And then all I need to do is count how many spaces I have. And again, you need to figure it out for not for the most spaces. In my case, there was one of the shorter pipes had more spaces than the longer pipes did. So you still need to figure out what the longest pipe is and the holes for that longest pipe. But that's it. So I hope that helps you. If you got any questions or comments or anything, of course, hit me up, and I will have the newest code on the GitHub as usual. And other than that, I'll see you tomorrow.